The following comments aren't meant as a criticism of Dispar. They're just trying to help him along, trying to work out what's really going on, because he's trying his best. He's learning what works and what doesn't work. And so I just wanted to make sure that nobody got the wrong idea through some errors that are creeping into his experiments due to the methodology. Thank you. I really appreciate the work that he's trying to do. Hello. I've been in some serious doubt about the validity of the measurements that Dispar was getting from his new photo gate, the way he's using it, because it's implying that to make something go twice as fast, all you need to do is halve the mass. Well, you could keep on doing that until something got ridiculously fast, couldn't you? So I think there's a flaw in his methodology, using hexagons and the placement of the stuff on the lever and so on and so forth. So I wanted to go back to my original ball launching thing, which is really Gary's design. So I thank him for that. I don't often thank Gary, but on that occasion I must, because that gave me absolutely excellent results, perfect every time. Whereas Dispar, he would acknowledge that he's getting haphazard results. The results change almost every time he does it. It lands somewhere different, lands further, lands short, lands to the left, to the right. Plus, we can't really see what's going on in his experiment. He stood in front of the camera, so all we saw was his back. So it lacks precision, plus it wasn't on a solid base, and numerous other problems I've discussed on his thread. Here goes. I'll just show you some experiments I've done. Doing this 120 frames per second as accurately as I could, getting the camera as directly above what I'm trying to focus on as I possibly could, and then counting the frames to check is it going twice the speed or not. It isn't. Anyway, so this is the first part where we look at the 62 gram ball and then the 31 gram ball, exactly half, being released from the elastic and counting how long the acceleration period is. Okay, so this first stage is just counting the acceleration period. Okay, this one is the 62 grams. So we've got 62 and 31 grams. 1, 2, 3, 4, 5, 6. The band is now as straight as it's going to be. So that was 6 frames for that distance. Okay.
Do the half mass.
If Dispar's measurements are right, then we should get 3, 1, 2, 3, 4. I'd say 4.5 because it's a little bit further ahead than the other one was. 4.5. The next stage is me counting after the acceleration period, when the ball is now free of the elastic band. So we're measuring now from the back of the ball. The image gets a little bit blurred, so if we measure from the back of the ball each time, then we're at least getting an honest result. So I'm counting from there to the first easily measurable point, which is the 100mm line. So I count how many frames that takes for each of the balls. Okay? And again, we observe that it's not going twice the speed. Hopefully you can see I'm merging the small ball picture with the large ball picture, so that I want you to be able to see a bit of both. 6 yards, so you can see a bit of everything now, I think, can't you? See how we gone with that? Okay. So you should be able to see both balls really now. Okay, so here we go. My apologies for some of the edits in this. I don't know what's gone wrong, but my editing thing keeps chopping off more than it was supposed to. So you'll hear half a word, or you'll miss me counting one of the steps. I'm sorry, it's just the way it's gone. It's too late to rectify it. Rubbish software for remake. So the small ball has just left the start line. Yes. I think we can say the small ball is there. Okay. And the large ball appears to be about there. Okay. Draw them both. So now let's count how many clicks it takes for the small ball to pass the 100 line. That's the 100 line, okay? 2, 3, 4, 5, 6. Okay, so it took 6 clicks to pass the 100 line. I'm circling around the blurred image. I know it ends up looking elliptical, but it's just to help people with poor eyesight. And that's the big ball behind it. 6 clicks to get to there, okay? Now you could be forgiven for thinking, oh, it looks like it's going twice the speed of the big ball, but wait a moment, hang on a sec. So this is where the big ball has passed the start line, okay? So let's count how long that takes to pass the 100 millimeter mark. So let's remember the other one took 6 clicks. 1, 2, 3, 4, 5, 6, 7, 8. It's just about past it. Well, just still over the line. So big ball took 9 frames to pass 100. So the small ball took 6 frames and the large ball took 8.5, 9 frames to cover the same ground to the 100 millimeter line. Now that's not a 2-to-1 ratio at all, is it? That's 8.5 compared to 6. You work it out, but it's not 2-to-1 ratio, is it? If the small one did it in 6, then the large ball should have taken 12, shouldn't it? If they were going at 2-to-1 ratio speeds. If Dispar's measurements were right, and the small ball was going twice the speed, then having measured it taking 6 frames to cover that distance, the large ball should have taken twice that. It should have taken 12 frames to cover that distance, but it didn't. It took about 8.5. I said 9, but you see what I mean? Not getting accurate results from the methodology. Don't want anybody to get the wrong idea, because it's really hard to remove a wrong idea once it gets in someone's head. It's dangerous, isn't it? Well, it's really hard to remove a wrong idea once it's in someone's head. Really hard. That's why we're in this mess in the first place. Because Gary believed some wrong ideas from the start. And it's become increasingly hard to remove those ideas because he just keeps doubling down on them. And so do his friends. They all back one another up. The honest truth is, nobody properly knows how these things work. We all just do our best to muddle through, and we are willing to admit when we're wrong.